Hi everyone, my name is Ruslan Kusov. I'm Cloud COE Director at SoftServe, AWS Ambassador, and currently I'm losing my voice. I have one more presentation today, but hope everything will be fine, at least for this presentation. So today I'm going to tell you about new era of platform engineering, particularly platform engineering powered by Agentic AI and self-service with Agentic AI. Let me grab my clicker. First, let me start with the concept itself, concept of platform engineering. I believe most of you may be familiar with this, but if not, it all started with DevOps. Remember this, DevOps, tools, people, processes, how we connect those things together, how we build something that will be useful for our developers. And it evolved, at some point of time, it evolved to platform engineering. So people, they started building what they call internal development platform or self-service platform. The idea is that if you have a large development team or teams, like 10 different teams, you would like to introduce some set of standards. Otherwise, you will end up with a situation when one team, they are developing their application using ECS, another team, they'll be using EKS, one team will be using Datadog, another team will be using CloudWatch, and so on. And that will introduce additional operational overheads, additional costs, and so on. And in order to avoid that, you would like to standardize. You would like to build some sort of like abstraction layer, the platform, that can be used as a self-service. So you just follow the standard and you just write your code. Pretty well for developers, and that's why concept became popular. And I really mean it, because we researched different sources. We worked with multiple customers, SoftServe originally, that's system integrator. And we compared our data with the data from Red Hat. As you can see on this slide, 85% of customers, they are moving towards platform engineering. So organizations, they would like to discover, or they are already using this platform engineering. As you can see, 18%, they advanced it. 14, they are just exploring. And 27, 41, that's like number in between. Process itself, from our experience, takes about 2 years. So if you're right now at this exploring stage, you need about 2 years to introduce mature practices of platform engineering in your organization. The problem is that there is no one-size-fits-all approach. So simply meaning that it is a complex product. It depends on your organizational culture. It depends on the way how you're organizing processes within your organization, what tools you're already using in your organization. As I mentioned previously, it's the way how to set standards and not to introduce any new tools, unnecessary tools. So how we can approach at that case? And at SoftServe, we decided that it makes sense to build some sort of like framework. So instead of telling that you should buy platform engineering solution, you should build platform engineering solution that will follow all your needs. So we introduced our own framework based on experience, based on our interaction with our clients, based on feedback that we received, and of course on collaboration with AWS. And that ended up with this concept that you can see on the screen, a concept where we have core components, EKS, ECS, or Lambda, because we are talking about microservices architecture, and all other components that will complement this microservices architecture, like microservices runtime. Observability components, security components, CI/CD, because we need to build containers, we need to test them, we need to deploy the storages, databases, third-party services. And of course, we have this IDP, Internal Development Portal, the tool that will be your interface, the developer's interface, to interact with this platform. So again, the idea is that all what you need to do is just to design integration interfaces and understand that in case today you're going to use HashiCorp Vault and tomorrow you're going to switch to Secrets Manager, you're not going to do anything with your code. So you just update this integration interface, CSI driver, for example, and you will get new tool securely connected to your environments, to your applications. Pretty cool idea. As I said, we call it SoftServe's Adaptive Modernization Platform, but it's not a platform, it's framework. I know things sometimes confuse people, but we're trying to follow AWS in naming services, our services. So this platform, we started with blueprints. So as you can see, it's all Kubernetes, reference architecture related to EKS blueprints released a couple of years ago. We have multi-availability zones. We have cluster components split by critical components and worker components. We have those environments isolated. We have best practices like Carpenter instead of Autoscaler to better manage efficiency and scaling capabilities of the cluster. And if we dive deeper, we'll also introduce some default components. Because again, remember that not everything can be solved with a Kubernetes alone. You should think about observability, security, CI/CD, and other things. And as you can see, we built this framework considering those other components. But they are built in the way that these components can be easily substituted. So again, if, for example, you don't want to use Argo CD for deployments, because currently you're using Jenkins and you're absolutely fine with that Jenkins, you can proceed with the Jenkins. But we'll give you a framework that will tell you what gaps you have in platform engineering, how you can fill these gaps with our default solution, and also a framework that will show you how to apply these platform engineering processes and practices for your organization. It worked really well till 2023, the year when people started experimenting with AI. The funny thing in 2023, that's the fact that a lot of people, they did not realize that AI was not something new. AI was born like 1956 with a small workshop. It evolved over the years, and 2023, that was a year of experiments and year of Gen AI, generative AI. I believe everyone had experiments with ChatGPT, with chats, bots, whatever. That's like common use cases. However, that was hype that distracted people a lot. And it distracted our platform engineering practices as well. Next year, that was year after hype, when people realized that, OK, so we created a lot of chatbots, a lot of experiments with the Gen AI, but how we move that to production? And 2025, we're still not in the production, and you can join my second session where I will show you some specific numbers about that. But 2025, that's the year when we're trying to identify business value of AI, Gen AI, Agentic AI, but we're trying to build a business case for our customers in order to move them to this AI era. Suddenly, we figured out that it's very well connected with the platform engineering use cases. So, SDLC. To be honest, I was not like surprised, but that was an honor for me this morning to participate in this keynote from Matt Garman. And he shared the same idea that in terms of SDLC, it is end-to-end process. So you cannot just take an agent for testing, agent for business, for the planning, for UI design. Because if you take just a single agent and not going to care about end-to-end SDLC process, you will fail. You will introduce yet another bottleneck. How it works? So let's imagine that you have a life cycle or SDLC cycle every 2 weeks. You have a new release every 2 weeks. You introduce testing agent. So now you don't need 2 weeks to test all your code. You can test it within hours. But your developers cannot develop the code within hours. They still need 2 weeks to develop new code. So you'll be waiting, sitting and waiting on the code that should be tested. Deployments, environments cannot be prepared in hours or days. We still need 2 weeks to prepare those environments. So instead of improving the process, you will introduce yet another bottleneck to that process. And in order to avoid that, you need to have this end-to-end solution. So again, we connected that with the platform engineering. What if, considering this SDLC as a common case or one of the best business cases for organizations to step up into this era of AI, Agentic AI, Gen AI, and so on, what if we connect that with platform engineering, one of the most mature cases that we had previously? And we decided to extend the idea of self-service portal with AI. So that's how we released IDQ, or AI-driven enhanced engineering with Amazon Q. Again, don't pay attention to the names. We are following AWS best practices in naming our services. So we released this idea of self-service powered by AI. And as you can see, it all based on the components that either available, like first-party agents from Amazon, Amazon Q, Amazon Bedrock agents, AWS Transform. Pay attention to agents that AWS released today, especially security agent, DevOps agent. That's something that we tested in a preview mode. Worked really well as an extension to this. MCP servers, custom agents, reusable prompts, LLMs. With LLM, it's the same situation as with engineers. Yes, so you have 2 different engineers with their background, with their experience, and if you ask them to do the same thing for you, one engineer can spend 1 hour, another engineer can spend 2 hours. You can get different results. They will work. They both will work, these results. But one result will be more cost-effective and scalable, another one less secure, for example. And the same with LLM. That's why it's important to choose the right LLM and provide this power of choice to your developers. So to highlight, it is yet another iteration of platform engineering. So we just introduced an enhancement for the self-service that brings these AI capabilities to the developers. This self-service, the idea of this self-service is to introduce nail gun. So if you're a constructor, you're building a new house, of course you can build a new house with just nails and hammer. That will take like months. Or you can take a nail gun and use that for the same purpose of building a new house within a week or less. The same with the platform engineering. And a couple of cases, so real cases before I jump to live demo. The first case, that's a case that we implemented for one of our customers. That's a case where we orchestrated this deployment CI/CD flow with the help of AI, with the help of MCP servers. Pretty simple case. So developer, in this case, needs to know only about programming language. So I know Java. I'm going to run or create my application in Java, and that's it. After that, I will put commit to repository, and everything else will be done by AI. So it will detect programming language, it will create a Docker file, build a container from that Docker file, deploy it to Amazon EKS using manifest generated by another agent, and will return me a status of deployment. If everything is OK, I'll get notification in Slack that it was successful deployment. If something is wrong, I will get notification that it is wrong, and analysis from MCP servers to CloudWatch and EKS about potential root cause for problem with my deployment. The second use case is pretty similar. So here you can see an example of model that we use it. We use Claude 3.7 Sonnet for that. The idea is that we build a tool for validation of deployments to Kubernetes. It includes validation of application components. It includes validation of cluster components, Kubernetes cluster components. But by the end of that, customer receives validated Kubernetes deployment. And after a production release, the customer can be sure that everything was fine and no issues happened during deployment. Or in case of any issues, that would be a rollback process with notification of root cause for that fail. Works really well in production environments, and we save it about 3 months of time for the customer by implementing that instead of rewriting the tool that they built originally using Golang. So again, to highlight, we're not going to build a product. It doesn't make any sense. We built framework. We don't have any software, proprietary software, intellectual property here, but we do have a framework that helps to accelerate deployments, accelerate application development, application modernization, migration, increase development productivity. And this framework follows all the best practices for security, high reliability, scalability, cost efficiency. So it's very well aligned with a well-architected framework. Now it's time for the demo. So it's live demo. So apologize if it's not going to work, but I'll do my best. And this demo about migration. That's an example of self-service. Yes. That's an example of self-service that can be done for the migration. So let's imagine that I'm running my data center. And in this data center, as you can see, it's connected through a VPN. I have my internal IP address for that. I can create some stuff here, add to my to-do list. It will be added. So it's a well-functioning application. Pretty simple architecture. So I have virtual machine with load balancer, 2 virtual machines with the application, and 1 virtual machine with the Postgres database. And I'm going to move it to AWS Cloud. So I'm going to use benefits of AWS Transform service. That's a service that allows me to run assessment, gets dependency mapping, qualify my service, run through right sizing exercise. But Transform works well for lift and shift. Unfortunately, lift and shift, that's a strategy for lazy migration. So that's the best strategy to introduce technical debt, but not the best strategy to run in a long term, in a long time. With that, customers, they prefer to find a way how to modernize, how to introduce replatforming and re-architecture at the beginning. So is it possible to perform replatforming, re-architecture with the cost of lift and shift? And with this demo, I'll show you that, yes, it's possible. And that's because of this self-service that we provided to our developers. So again, on the left-hand side, that's architecture that I have right now. On the right-hand side, that's something that I'm going to build. Load balancer instead of virtual machine, I'm going to use managed service, RDS with the primary and replica setup, multi-AZ deployment, and my application converts it to containers, containerize it, and deploy it to EKS. So application itself, that's a Java application, as you can see. And what we built this agent. This is a fancy web UI that I added for the purpose of this demo, but this is the agent that can be integrated to IDE of your choice. So Visual Code Studio, whatever else that you're going to use, it can be easily integrated. And what I'm going to do, I'm going to show you that I have my, and that's what I'm talking about. So I have my servers, and I have my servers discovered by Transform. Thanks God I saved this file earlier, so probably I'll skip this part with AWS console, so you should trust me. But that's a file generated by AWS Transform agents. So with AWS Transform, what I did, I used discovery tool, so we can read about this discovery tool to get this CSV file. So this CSV file identified instances, their IP addresses, and roles: client, database, client, load balancer. According to that, again, I'm sorry, but I need to log in again to my console, so I'm not going to show you visualization, but we can chat offline after this presentation. But we're going to back to this tool that we built, this agent that we built for modernization. And all of what we need to do is just download our files, the CSV file and WAR artifacts for this Java application to S3 bucket. That's pretty much it. Everything else is just to push this button, start analysis. And under the hood, that's the implementation of this self-service. So particular version, Java containerization agent of that self-service, the use case, developer who is operating on-prem but going to migrate to the cloud with zero knowledge of the cloud itself, with the zero knowledge of cloud services, but I'm going to migrate my application to reference architecture with the containers, with the load balancer, with RDS managed service, and I'm going to use AI for that. I'm going to use these capabilities of self-service connected with AWS Transform. So we're going to wait for a couple of seconds just to have it fully generated. And I will show you what this tool actually creates and how it can be used for the next steps. So meanwhile, just a reminder that we are going from this legacy lift and shift to this modernized environment. Yeah, still no access. I actually like this fact of live demo because it shows you real time that is needed to create this conversion, to generate all the files, generate all the manifest deployment, Docker file, and actually have something that can be easily deployed to live environment. So technically, within this live demo, you're just watching the process of real migration for this simple application. And in order to understand what does it mean for you, for your cases, if you have large migration, planning to migrate 1,000 VMs, all what you need to do is just multiply that by 100 or 1,000 to understand how much time you need for that modernization. OK, so generating recommendations. I hope it will be here soon. Yeah, so meanwhile, again, unfortunately, I cannot show you what's going on, but AWS Transform has integration with Migration Hub. It will be deprecated. Service itself will be deprecated. However, right now, through this Migration Hub, you can see the list of servers. You can see dependencies, so this network map dependencies. And this file that's actually exports from that Transform Discovery tool. So that's pretty much what you can use, and you can see in a Migration Hub planning your migration. But again, reminder that Transform supports just lift and shift migration, nothing else. OK. Live demo, yeah, running a bit late. Probably like people using Bedrock proactively, because under the hoods, we're using Bedrock, we're using API, we're using connection to Bedrock and predefined prompts. So we defined LLM, we build these custom agents, custom MCPs, and we predefined prompts that can be used in order to run this request and create results that will help me to modernize my application. Wrapping up. So by the end of this demo, I hope once I'm done with my presentation, we can chat offline. By the end of this demo, you will have generated YAML file, Docker file that will help you to deploy application. YAML file that will help you to apply and deploy this application to Kubernetes cluster. And you will have step-by-step instruction how to move your database. So snapshot that should be taken first. Oh, yeah, finally. So as I said, it took more time. So it's like results of the analysis with all deployment roadmap, preparation step, application containerization step, Kubernetes deployment, load balancer configuration, database migration, validation testing, and details. So as you can see, Docker file for your application, build command for that Docker file, Kubernetes deployment, Kubernetes services, config map, variables, and configuration for other resources, including CDK code for infrastructure as a code for load balancer, and CDK for a database service. With that, coming back to my presentation, that was an example of self-service that we introduced for our customers and for our developers. It accelerated a lot our migration practices and modernization practices. So in average, we can see 2 to 3 times improvements in terms of time needed for migration and modernization. And last but not least, it is the way to do a migration with the replatforming and re-architecture strategy instead of lift and shift and instead of introducing this technical debt. And with almost zero cloud knowledge. So the way of proper use or use case for self-service. Thank you very much.